Hello, George Romanic here. Welcome to Fundamentals of Weather and Climate playlist. In today's video, we are going to talk about the reflection of solar radiation off the Earth's surface and the concept known as albedo. Very simple video. Again, we start by examining this figure that we are familiar with now. We have top of the atmosphere, this is the surface of the Earth, and we have a certain amount of solar radiation that is reaching top of the atmosphere, known as solar constant, 1367 watts per square meter. And we are looking into various processes that are occurring in the atmosphere after this light enters the atmosphere. So we said one possibility is for this light to be scattered, and that's a separate video on Rayleigh and Mie scattering. Another option is for this light to be directly transmitted to the surface of the Earth. And the third option is for this light to be absorbed somewhere in the atmosphere by atoms, molecules, or some other particles. We examined this normal light in one of the previous videos. We examined diffuse light. In another video, we will examine absorption in a separate video, but today we will examine the concept of this light being reflected now off the surface of the Earth. And the question is, how much light, incoming solar radiation, is being reflected by the surface of the Earth? The amount of reflected light is known as albedo. And albedo of our planet is 0.3. That means that 30% of solar radiation that comes to our planet is reflected by the Earth and the atmosphere. Because remember, the atmosphere could also reflect light, just like the Earth. But it is more likely that the light is reflected by the Earth rather than the atmosphere. So what I'm saying is, if this is the surface of the Earth, we have solar radiation that is coming at the surface of the Earth. It can be direct or diffuse, doesn't matter. It can be absorbed, but it can also be reflected. And you know from maybe high school physics, then when it is reflected, then the angle of incidence has to be equal to the angle of reflection. Very famous law. Now, the albedo, or the amount of reflected light, clearly depends on the type of the surface. Bright surfaces, such as snow, reflect a lot of light, whereas darker surfaces, such as forests and water as well, reflect very little and tend to absorb much more. This is one of the reasons why it is difficult to look at fresh white snow, because white snow can reflect up to 90-95% of incoming solar radiation. So sometimes it's similar as to looking directly into the sun. So much light is being reflected. Yet you have no problem to look into the forest. Moreover, it's very relaxing to look into the forest because a lot of light is being absorbed and it doesn't blind your eyes. So this is the concept of reflection and albedo. Albedo of our planet is 0.3, but now I would like to show you a table that lists albedo of various surfaces as well as celestial bodies, so you can use it perhaps in your studies and references. Let's check it out. Here is a map that shows albedo of our planet averaged only over 16 days in a year. And you can see that certain areas have very low albedo, whereas some other regions, here very high latitudes, have very high albedo. That was because these high latitudes are covered with snow. And as I just said previously, snow has very high albedo. Some tropical regions also have high albedo due to very deep clouds over there that can reflect a lot of radiation. Whereas certain parts of Eurasia, South America in this particular case, had very low albedo of about 0.2 or so. But keep in mind that albedo is changing throughout the year for the reasons that we discussed. So if we took this map during some other part of the year, the situation might be different. And lastly, here is different type of surfaces, and here is value of albedo in percentages for these surfaces. So as I said, fresh snow can reflect a lot of light, much more than ice or sand. Sand has very low albedo indeed, but then again, some types of snow have larger albedo than some other. Grassland, so on. You can see that forest has very low albedo, 3 to 10%. So a lot of radiation is captured because forests are green. That's rather dark color. Thick clouds have very high albedo, as I just said, whereas thin clouds not so high albedo. And as I said, Earth and the atmosphere have albedo as a global albedo of 30%. Here is albedo for some other celestial objects. Until next video, goodbye.